Today's class we will discuss about work. Do you know what is work done and how do we calculate? Work is simply is equal to force time, so you can take some notes, is equal to force time distance moved in direction of force. So the work is equal to force time distance moved in direction of force. This is how we can define work done. In direction of force. In direction of force. So we can also say work is simply equal to force time distance. Force time distance. Next thing we need to understand what is power, how we can define power. So can you please tell me how to define power? Power simply we can define power is equal to work done divided by time. So work done divided by time. So this is how we define power. We can also write down W over T, or we can write down W is equal to FD divided by T. And if you look at this part, D over T, this is equal to velocity, so we can also say power is equal to F times V. Next thing we need to understand is about efficiency. So can you try to recall what is efficiency? This is simply equal to useful energy output. Useful energy output. So simply we can define this is equal to useful energy output divided by total input energy. So here we can write down total input energy. This is how we can define efficiency. But you can also define out this one. This is equal to useful power output. We can also define this is equal to useful power output divided by power input. We can also define efficiency in terms of power. So this is how you can define efficiency as well. Next thing we need to understand what is percentage efficiency. If I ask you percentage efficiency, so simply you need to multiply on right side with 100. So this is percentage efficiency. So this is how you can define percentage efficiency. Next thing we need to understand is about kinetic energy. Kinetic. So can you please tell me what is the formula for kinetic energy? Did you remember what is the formula for kinetic energy? If you remember, you can write down. Otherwise, let me explain to you. Kinetic energy is simply this is equal to 1/2 mv square. M is the mass. So m here is the mass. V is the speed. So this is the speed. So this is how we can define kinetic energy. Often we write down this one Ke. K for kinetic, E for energy. Kinetic energy. Next one we need to understand is gravitational potential energy. Gravitational potential energy. So next thing we need to understand is about gravitational potential energy. Gravitational potential energy simply is equal to mg delta H. So this is how we can define gravitational potential energy. Is the work is a scalar or work is a vector? Work is a scalar or work is a vector? So please tell me, work is a vector or work is a scalar? Work is vector or work is scalar? Type here, is it scalar or is it vector? Okay, work is a scalar. Okay, please, you need to understand work is scalar. No, work is scalar. Work is not vector. Work is scalar. So you need to understand work is scalar. Work is not a vector. Work is scalar. So work is not a vector because it has no direction. Excellent. So it is scalar. It is not vector. Okay, excellent. So this is a scalar. This is not vector. So this is not vector because work has no direction. So work has no direction. That's reason it is scalar. And work is a form of energy. Work is equal to energy transfer. You also need to understand when you do work, it means you transfer energy. Look at this one now. I have this bottle here. You can see if I want to give my energy to this bottle, I can raise this bottle up. So I transfer energy. So work is energy transfer. So simply you can understand work is energy transfer. And any form of energy has no direction. So any form of energy, very important, any form of energy is a scalar. Any form of energy is scalar. Very important point you need to understand. Any form of energy is scalar. Any form of energy is a scalar. Now, can you please tell me, kinetic energy is a scalar or kinetic energy is a vector? Kinetic energy, can you please tell me, is kinetic energy vector or scalar? Kinetic energy is a form of energy. Any form of energy is a scalar. Excellent. So, kinetic energy is scalar. So, we can write down kinetic energy is scalar. Excellent. How about next one? Gravitational potential energy. Is it scalar or is it vector? Gravitational potential energy. Is it scalar or is it vector? So this is also scalar. Why? Because it is also form of energy. So we can also write down this is also scalar. Now next thing, let me ask you, how about heat? Heat is a vector or scalar? Heat, is it vector or scalar? It's a form of energy. It means this is scalar. Any form of energy is scalar. So this heat is also scalar. So you have to understand any form of energy is a scalar. Heat is also scalar. Now let's go back to power now. Is the power, it's a scalar or is it vector? Power, is it vector or is it scalar? Power is also scalar. So this is scalar because power also has no direction. So this is also scalar. So work is a scalar. You can also understand from here. Work is scalar. Time is scalar. So power is also scalar. Okay, excellent. We have studied basics now. Now we will do some past paper questions. So if you have any question about this knowledge, you can ask me right now. Otherwise, we go and do some past paper questions. You can write down, you can take some notes about this one, and then we practice some past paper questions. Okay, so you can take some notes, you can write down, and then we go and practice some past paper questions. Let me clean this board and go to next one. Excellent. And tell me, what is your answer for this question? Read this question and try to answer. Question is asking you, you need to calculate the power. How much power? So the power you need to calculate. In this case, the best way to answer this problem is write down what is given. So what is this? This is the force. So simply we can say F is given. So this is the force. This is equal to 50 newtons. We can write down. What next is given? This, you see, height is given. So the next thing, you can write down height, or you can simply say the distance is given, and that is 6.5 meters. Next, time is given. Here time is given. So we can write down this is 7 seconds. What we need to find out? We need to find out power. So this is what you need to calculate. So the best way to answer this problem is simply, first thing, we can write down power. This is equal to W over T. And W is equal to Fd over T. So this is Fd over T. Now you see, force is given. Force is 50 newtons and distance is given. This is 6.5 divided by time. Time is 7. So now tell me, what's the answer? Just type A, B, C, D. Okay, try to answer quickly, please. You can just type A, B, C, D. Okay, you can simply look at this one now. You see, we see 50 here, and then you have 6.5, then you have 7, and this is, you can compare with this one. So our answer for this question is D. So this is the answer for this problem. So this is the answer. Let's move on to next now. First, read question. Take some time, read question. Again, we need to start from what is given. So first of all, you need to write down what is given. In this case, weight is given. So this is simply force. We can write down the force is given. So this is 600 newtons. We can write down. Next one, total height is given. That is 4 meters. So we can write down the total height is given. That is the distance. And this is equal to 4 meters. Next one, time is given to us. We can write down T. This is equal to 3 seconds. Question is asking us, we need to calculate power. So this is what we need to calculate. So we can also write down what we need to calculate. Power we need to calculate. The next step is, you need to write down power in terms of force, distance and time. So this is how we can write down in terms of force, distance and time. Force is given, this is 600 newtons. Distance is given, that is 4 meters. Time is given, that is 3 seconds. Now simplify and you will get the answer. Simply you need to calculate. Simplify this one from here 60. So this is 20. This is 200 times 4. This will be 800. So our final answer will be 800 watts. So the answer for this question is B. Any question about this one? Okay, please try this question first. Read question and try to answer. First try by yourself. Again start. First step, what is given? So you need to write down first of all what is given to you. This is the first step. For this question, if you read, it is given to you a 300 Newton force is applied to a box. Means the force applied on the box is given, and that force is equal to 300 newtons. We can write down 300 newtons. This is given, weight is given, but weight and distance, you see the box is moving this way, so distance is this way, so you have to take this force in direction of distance. So you can simply ignore this one, no use of weight. So the force we have 300 newtons in direction of distance. Now next one, distance is given. Distance is given also here. You can see here. This is given 3 meters and the time is given, that is 20 seconds. Question is asking us, we need to find out power. So average power we need to calculate. So power is simply equal to W over T. Or simply you can say W is equal to FD. This is divided by time. So our final answer, you can just plug in values for force, for distance and for time. Time is 20 seconds and you can find out your final answer. So in this case 0 you can cancel with 0 and 2, if you divide by 2, 15, multiply by 3, this is equal to 45 watts. So our final answer is 45 watts. So this is the answer. This is the answer. So the answer is A. Okay, if you have question, you can type your question. If not, then we move on to next one. Okay, let's try this problem now. Again, the first step, you need to write down what is given. So if you read, it is given to you, the weight of this person is given, that is equal to W. You can write down here, this is equal to 500 newtons. And when the person reach at this point, so person is here, we need to find out how much power is developed by this person. So simply, first thing you need to write down the force, that is 500 newtons. And the time is given 10 seconds. She took time 10 seconds from this point to this one. So the time is given, that is equal to 10 seconds. Vertical height is given. So vertical distance is given, that is D. And this is equal to 5 meters. We need to find out power. So again, we need to calculate power. Next step, we need to write down power in terms of force, distance and time. So this is how you can write down. So the force is given, that is equal to 500 newtons. Distance, that is 5 meters. We can write down 5 meters here and we need to divide by 10. That is the time. So simply you can cancel and you can multiply and you will get your final answer. So the final answer in this case will be 250 watts. So the answer for this question is C. So very straightforward one based on the same concept. So any question about this one? Can we move on to next if this is clear to you? Here is the answer. So the answer for this question is C. Take some time and try to answer. This question is about efficiency. Very straightforward one. Just type your answer. You don't need any calculations. So is A is possible answer? A is not possible answer because this is wrong. You see, this is not possible answer. This is telling you total energy input minus useful energy. So this is wrong. This option is not possible. Now we move on to next one. Efficiency. Let me write down the formula for efficiency here. So you can recall efficiency is simply equal to useful energy output. So this is useful energy output divided by input energy divided by, you can say, total input energy. So total input energy. So this is how you can write down total input energy. Now you simply need to compare this one with given options. If we compare this one with given options, so C is the correct answer, but D is not correct because this is telling you total energy input. So this is wrong. This has to be here actually, and this has to go here. So this is wrong with this one. So D is not possible option, B is not possible option, C is the best possible option. So C is the answer for this question. Very straightforward one. So let's go to next one. Simply you need to understand efficiency is equal to useful energy output divided by total input energy. Let's move on to next question now. Try this one first by yourself. Take some time and try to answer. Always start writing what is given. First of all, write down what is given. In this case, you can see the input power to a motor. Input power is given. This is 300 watts. So we can write down input power. So input power in this case is given, and this is equal to 300 watts. So this is the first thing we need to write down. The second thing you need to write down time. Time is given. So we can write down T is given. This is equal to 20 seconds. And the force, the weight is given. So this is force that is given. And this is equal to 400 newtons. Height is also given. Height is given. This is equal to 6.0 meters. We need to find out efficiency. So height, simply this is equal to distance. We can write down distance. So we need to calculate efficiency. Very important point, little bit tricky one, but very nice question to understand concept. So let me write down first of all efficiency. This is equal to useful energy output. This is equal to useful energy output divided by total input energy. Total input energy. So we can simply write down divided by total input energy. Now you need to find out what is given to us. Input energy is given. So this is given. Input energy is given. So simply you can write down input energy here. So this is equal to 300 watts. But how about useful energy output? Is it given to us or not? This is not given. That it is given to us, the box, the weight of the box is given. This is equal to 400 Newton. We lift this one up vertically upwards to this certain height. So this is to certain height. So we can take distance from center to center, and this vertical height from center to center is given. This height is 6.0 meters. So we can write down D is given. This is 6 meters, and the time taken from here to here is also given. So we can write down T is given. This is equal to 20 seconds. Now from here, can we find out energy output? From here we need to find out energy output. So you need to find out energy output, but in this case you see input power. This is input power. So we have to find out useful output power. So we will write down here output power you need to find out. So output power you need to find out. Output power, simply that will be equal to FD divided by T. So in this case, simply you see the force is 400 and the D, the distance is, this is 6 meters, and the time is 20 seconds. Now you need to simplify this one. So this 0 you can cancel with 0, and 40 divided by 2, this is 20, and 20 times 6, this will be equal to 120 watts. So here we need to write down useful power output. So one thing you need to understand, this is energy. You can also write here power, means efficiency you can also write down in terms of power. So here we are using power. So here energy we are using power here as well. So you can see here, this is 120 watts. We need to calculate percentage. So we need to multiply right side with 100. Now if you multiply 0, you can cancel with 0, and you can divide this by 6, so you will get 2 here, and here you will get 5. Now if you multiply 200 divide by 5, your answer will be 40. So this is 40%. So efficiency of the motor we need to calculate, and that is equal to 40%. So our answer for this question will be C, and this is the answer. So is it clear? Any question about this one now, please? Just few points you need to understand. One point, energy you can replace with power. You can use useful power output, or you can use useful energy output. In this case, power is given, you will use power here. Rest is the same. Follow the same steps and you can calculate your answer. If you have any questions, you can try. If you have no question, then we move on to next one. Okay, very nice question. So now please try to answer this problem. Very nice question, very nice past paper question to check your understanding of this chapter. So let's try to answer first of all this. For this question, you need to read actually 4 people of equal weight. Very important point. Equal weight means W is the same for all these persons. We can also draw simply here persons. There are 4 persons. They are standing here. You can draw here. These are 4 persons. They are standing at this point. On a beach, use different routes to get to the top. Means these people, they come to this top, they reach this top, they follow different routes. So they follow different routes and they reach this top. Question is asking us, we need to find out which person produces the greatest average power. This question is little tricky one. So let me explain you first. Power is equal to work done divided by time. Power is equal to work done divided by time. In this question, we need to calculate work done against gravity. Against gravity. So we need to calculate work done against gravity. So the work done for all these people, they will, even they go from this way, one person climb up this way, and if one person go and follow this ladder, go up, the work done against gravity will be the same. So work done against gravity, this will be the same. So this is the point you need to understand. Work done is same. Work done is same. Work done against gravity is the same because they go raise the center of mass by the same height. They will go up. So otherwise you can also say in this case work done is equal to mgh, or we can say that work done is equal to W time h. W for every person is the same, height is the same, this one is the height, this height is the same. If W same, height same, it means work done is same. So we can write down power is equal to WH over T. This is the same. Now we need to find the greatest power. Means this has to be the greatest. So the time has to be the smallest. Means the shortest time. If you look at options now, this time means the C. This is the shortest time. Shortest time. So this is shortest time. So the answer for this question has to be C. Okay, so this is how you need to approach this problem. This is how you need to answer. So this is the main concept. Work done. Work done against gravity. This is equal to mgh. Or simply you can say this is equal to W times H. This is the same for all of them. So you just simply look at time. If time is the shortest, power will be the maximum. Means the greatest power. So this is how we can calculate. Work done against gravity in this question is the same. So let's move on to next question now. Okay, here is one very nice question. So please read this one first of all. It's not very difficult, but very nice question to understand work and power. So please try first of all by yourself. Start from first step. Always write down what is given. So you have to start from given. Which row represent the situation in which largest amount of work is done? Amount of work is done. Now, if you look at this one, force is given to us and distance is given. So we need to calculate work done. So work done simply is equal to W is equal to FD. So work is equal to FD. We have force, we have distance. So we need to calculate work. If you need to calculate work done for A, we can say work done by A. This will be equal to 40 times 2. So the work done will be 80 joules. So we can write down 80. And work done by B, we can also write down here. This will be 2 times 10, so this will be 20 joules. If you go to next option, you can see work done by C, 20 times 6, so this will be equal to 120 joules. The fourth one, work done by D, this is simply 100 times 1, so this is 100 joules. Now simply you need to find out the largest amount of work, and largest is C. So this is the largest work done. So our answer for this question will be, the best option is C. So C is the answer. So any question about this one, please? Is it clear to you? This question is pretty straightforward one, but very good to understand concept about work done. Okay, excellent. So let's move on to next now. Okay, let's move on to next now. If this is clear to you, let's move on to next one. So please try by yourself first of all. You need to understand this question and then you will be able to answer. Let's try to understand this problem and work together. You can see a stone of mass m is held at rest in water. So the first thing you need to sketch. The best way to understand problem is you need to sketch. Answer is D. No, answer is not D for this problem. Answer is not D for this one. So let's try to understand. Let's try to sketch. So it is given to you, stone is held at rest in water. We can imagine the stone is at this point, at rest. Rest means its initial velocity, this is equal to 0. So simply we can write down u is equal to 0. If the velocity is 0, how about kinetic energy of the stone at the beginning? That also has to be equal to 0. So kinetic energy is 0. The stone is released and falls vertically. So the stone falls vertically, means it goes like this. Let's say it reached this point, at this point. So when it reached at this point, it is also given to you, as it falls, resistive forces cause the temperature of the water and stone to increase. We need to calculate work done against the resistive forces. So to answer this problem, simply you need to understand conservation of energy. So simply we need to write down conservation of energy. So based on this principle, we can answer this problem. So we will write down conservation of energy. Means energy initial. Energy initial is equal to energy final. So simply we can write down final. First of all, you need to understand at this point, let's say this is here lowest point. So you can see the height is here. So this is the height h. So the initial kinetic energy is 0. Initial GPE, we can write down this is equal to mgh. So this is initial energy. This is equal to mgh. At this point, GPE, we can assume this is equal to 0 here at the ground. GPE is equal to 0. So you can write down here, at this point, it has velocity. Stone is falling down with constant velocity. So it has certain velocity. So it means it has kinetic energy. But also we need to understand, when the stone is falling, stone is hitting water particles. When the stone is hitting water particles, stone do work against water particles. Stone apply force on water particles apply force on stone. So when stone hit water particles, the speed of water particles increase. It means water particles gain energy. So we can write down there is a work done against friction. So this is WF. Now question is asking you, you need to find out WF. How you can find out? that is simply equal to mgh minus 1 half mv square. So the answer for this question is B. This is what question is asking.